Good day, ladies and gentlemen. This is the intro to compounds, the beginning of chapter 6. That was a horrible circle. I'll try that again. The date today is Monday, April 6th. It actually isn't the day that I'm recording the video, but that's completely irrelevant to you, so it doesn't matter. This is for my grade 9 science class, but whoever you are watching this video, welcome. If you don't know me by now, Mr. Benjamin. That's definitely an N and a Y put together, but it looks like an M, so I'm going to change that as well. B-E-N-Y, there you go. And smiley face, and let's move on. Learning goals for this lesson. So, we're going to define what a compound is. We've talked about compounds before. We think back to elements. And we know that elements are found on our periodic table. Do a rough outline of what a periodic table should kind of look like. God, it's going to be a lot harder than I thought it would be. Yeah, something like that. Anyways, the periodic table is filled with elements. Compounds are different, but very similar at the same time. We're also going to give examples of common elements, things that we have around the house maybe, things that we should know about. We're also going to describe the difference between two big ones, ionic and molecular. These are the two specific types of compounds. They are very different. They have very different properties, and they'll react differently in different situations. So it's very important that we can describe the difference between the two of them. And finally, we're going to recall valence shell electrons. Now, that's very important when it comes to bonding. Why is that important? Well, a compound is defined as a pure substance made up of two or more elements. These are bonded together. I don't like how any of that looks right there, so I'm going to write that again. Bonded together. All right, some examples. Very common example, one that I love using, is salt. I hope that came out okay. Now, salt. It's a white substance. I'm just going to color it in yellow so you can see what I'm talking about. It all kind of looks the same. It's granular, but it's actually made up of two things. The chemical formula for salt is NaCl. Na is sodium. In fact, I'm going to write this different colors here. Sodium. And Cl is chlorine. When we name our compounds, we actually change the end. So in total, this becomes sodium chloride. But that we'll worry about in the next video. So salt is made up of sodium, which we know is a metal by looking at our periodic table, and chlorine is a gas. So this is a metal and a gas put together. Now metals have specific properties, gases have specific properties. How do they end up as a white powder? Well, that's based on their bonding capabilities, which we'll talk about in a bit. Another example, another very common one. I really hope this shows up better on the screen when it's recorded. It's carbon dioxide, CO2. Let's write this like this, CO2. Put a line there. We know C is carbon, and O is oxygen. There's actually two oxygens, as we see here, and we use different prefixes, and we'll talk more about that in the next video as well. But since there's two oxygens, it's known as dioxide. Because in this case, di means two. One more quick example. Now this one just looks like fire, but it's a very specific type of fire. This is a natural gas burner. So if you have a gas stove at home, this is what your kind of stove looks like when you turn it on. I've always been mesmerized by the appearance. This natural gas is actually called methane. Methane I talk about a lot. I make jokes about it, but it is very important to our lives. CH4. It's fine. Carbon still. And we know that H is hydrogen. And I know there's a hand here somewhere, so you might not be able to see it, so maybe I can write it up here for you. Methane. These are all compounds. You can tell they've all been made, or they're all comprised, or composed, I should say, out of elements that you would find on the periodic table in very specific orientations and ratios. When they have the right ratio and orientation, they develop certain properties. For example, salt is a white solid. Carbon dioxide is realistically, it's colorless, but it's a colorless gas. And methane, kind of smells bad, and it creates fire. It's very explosive. It's very combustible. Different types of compounds. So two very, very, very important words to know. Ionic and molecular. An ionic compound always consists of one metal and one nonmetal. So again, if you're looking at your periodic table, I'll do that quick drawing of what it kind of looks like. Might not look like this at all, actually, but, whatever. Generally speaking, our metals are over here, and our nonmetals are here, and metals actually kind of continue up to that point. So for an ionic compound, you have to have one from this side and one from this side kind of bonding together. For a molecular compound, it's actually made up of two nonmetals. So molecular, in fact, let me do this one in yellow. Molecular compound would be two nonmetals put together, so they would only be from this side. Examples. So on our previous page, if we look at the first one, NaCl, and in fact, let me kind of copy this whole thing here. Hopefully it doesn't come out too weird. Yeah, it looks okay. For some reason there's a D here. I'm going to get rid of that. We talked about sodium being a metal. Sodium is actually a group 1 metal. Element number 11, I think? Yeah. And chlorine is number 17, and that's a nonmetal. So salt would be ionic. That's right. Let's get rid of that. We'll write it out. Sodium chloride. And here we have a metal plus nonmetal. Let's look back on our previous examples. Carbon dioxide. Carbon dioxide? No, thank you. Dioxide. These are both nonmetals. And we can also talk about how carbon dioxide is CO2, but we can also do CO, which would be carbon monoxide. I'll write it underneath. Monoxide. Keeping in mind that mono means one, di means two. And again, next video, we'll talk more about naming. Not important right now. Most important thing to remember, ionic is one metal and one nonmetal. Molecular, two nonmetals. And I also wrote none here. I hope someone caught that. It's actually supposed to be non. Okay, thinking about bonding and electrons specifically, we need to recall valence shells. This is the outermost shell, and the pattern for holding electrons is 2, 8, 8, 18. This is all in the previous video. Ooh. I believe that was on BR diagrams, Bohr Rutherford. BR diagrams. So we talk about the valence shell. It's the outermost shell that has electrons. If you have a full valence shell, you are non-reactive. Another way of saying this is happy. Very happy with your full shell. You don't need anything else out of life, so you're going to be non-reactive. If we recall group 18 of the periodic table, these are called the noble gases. or inert. And they were unreactive. I'm not sure if the right way of saying it is non-reactive or unreactive. I'm going to go with both because I think it's okay. Correct me if I'm wrong. If you think about group 1, I'll write this in red because red's a bit of a more aggressive color. These were the alkali metals. And they were highly reactive. Metals, I'm going to underline that. If we also think about group 17, halogens, these were the most reactive gases. Okay, group 1, group 17, What do we know about sodium and chlorine? Is sodium a group 1 metal? Pretty sure it is. Is chlorine a group 17 metal? Pretty sure it is. Group 1, group 17. Something about sodium and chlorine together makes them very happy, makes them salt, which is kind of weird because you don't think about salt being happy. You think about salt being kind of like, I don't know how to describe the slang. Someone can describe it for me. How do you know what group has what charge? Describe it. Okay, well, let's look at it. Let's look at the group numbers. Group, let's write that again. Group 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, that doesn't work. Ignore group numbers. I'll keep 1 and 2, though, because those numbers are the same. Now, what about group 18? 18 was very unique because we said group 18 on the periodic table was unreactive. They had a full shell. So this group needs to lose or gain 0 electrons. Group 1 wants to gain 1 electron. Excuse me, did I say gain? They want to get rid of 1 electron. Lose is a better way of saying that. Lose 1 electron. Group 17, wants to gain 1 electron. Let's do that in yellow. And we just talked about how chlorine and sodium were great friends. So they are going to create let's make this bigger. NaCl. Now, I've written all over this thing, but this said charge of ions. Group 1 will always want to lose 1 electron. If you lose 1 electron, you're going to become positive because you're losing a negative. Group 2 wants to lose 2 electrons, so they're going to become positive too. That will go all throughout. If we start from the other side, group 18 is 0. Group 17 wants to gain 1 electron, becoming more negative. Group 16 wants to gain 2 electrons, so they'll become negative 2. Group 17, 16, 15. Group 15 wants to gain 3 electrons, so they're going to become negative 3. This is how the bonding process works. And remember, this is all based off of the electrons on the valence shell. So if they want to gain 1, 2, 3 more, that would have a charge of negative 3. A lot of confusion, all these questions will be answered in the next video when we start to name. As I just said, the next video will contain naming and drawing compounds, and we're going to look at Lewis dot structures. So keep this in mind, and until then, I've used pink for a long time. Let's pick a new color. How about purple? How does purple show up here? Smiley face. Thank you. Hope that works. I hope everyone can see that. I can barely see it. I might change it. Anyways, have a great day.